and move it into your templates, and then invoke it instead of writing it over and over again. So these templates are great, not only to get people looking at and building code in a different way and far below the skin surface of your code, but also to improve your productivity. Also, don't manually format your code. In the bad old days, and in fact, I think you'll even see some tips on formatting inside the documents I just showed you, the standardization documents. In the bad old days, we would manually format our code, but hopefully you're working with an IDE, some kind of developer tool, that will automatically format your code for you. For example, here's some really nasty looking code, and I could sit here and reformat it manually, and I remember very well doing this in the old days because I'm very picky about how my code looks. I want to get, for example, the from keyword lined up right justified with the select keyword. But now instead of doing that, I just do a right click, format, or click on the formatting icon, or Control Shift F, and it reformats my code for me. So take advantage of these features in your IDE to accelerate and standardize the development of your code. So that's a discussion about standardizing your coding standards and naming conventions. Let's talk about handling, logging, and communicating errors. In general, people don't like to deal with the negative. We like to deal with the positive. And what that means in programming is that we tend to focus on assuming our programs will work correctly and don't focus on the negative, which is, well, what happens when errors occur? However, it's very important that you do proactively think about how to handle, log, and communicate errors. And the key aspects of doing this are, first of all, take full advantage of PLSQL's error management features. And I have a whole separate video series on error management in PLSQL that talks about all these different features and also the best practices that I'll talk about right now. Make sure that you communicate problems in a consistent way to both users and support, and make it easy for developers to quickly and easily handle and log errors. This is the kind of standardization, these are the kind of principles that should drive the standardization of your management of errors and error handling. If you let everybody do whatever they want to log errors, to handle errors, to communicate errors back to your users, you'll have a total mess in your hand, and it will be very difficult to identify the source of bugs and fix them, a key aspect of maintainability. Instead, what you want to do is create and have everybody use the same utility to do all these different operations. A shared error management utility. It's the only viable solution to standardizing error management. And if you don't have one of these already, and many of you will, check out the Quest Error Manager at PLSQL Obsession. It's one of several different utilities available on the website. Right here, Quest Error Manager. And it's a freeware tool that will do error management, application tracing, replacements for dbmsoutput.putline, assertion routines. In general, you need to make sure you have a single shared utility in place. I offer one, there are others out there. And if you want more details on how to do this standardization and the key principles behind organizing it, check out the Error Management in PLSQL series of videos. I won't go into more detail here. Third area of critical standardization, minimum amount of standardization that you should do, is how, when, and where to write SQL. Again, I'm going to cover this at a fairly high level, but I'll be focusing on it more completely in Say Goodbye to Hard Coding and Best Practices for Writing SQL. But here's the thing for you to think about right now. Many organizations, including I'm sure yours, have some kind of coding standards. How should we format our code? How do we name our programs and variables, etc.? The kind of things that are covered in these standards documents which I just showed you. Strangely enough, though, very few organizations have standards for when, where, and how to write SQL statements. We just take SQL completely for granted. It's so easy to write in the PLSQL environment. But that, I believe, is a very strange and very dangerous thing to do. SQL statements are among the most problematic aspects of our applications. They're always changing. They cause most of our serious performance issues. The SQL statements in our applications are often the Achilles heel of an application, the aspects that make it the hardest to write good, successful, performant, and maintainable applications. Now again, I'm not going to focus in detail in this lesson about how you standardize SQL, what the best practices are. merely point out that this has to be done. You have to set standards. You need to follow best practices for writing SQL and PLSQL, or your application will fail. And for more details, check out Say Goodbye to Hard Coding and Best Practices for Writing SQL in PLSQL. And you'll get lots more information there. But as a quick overview of key SQL standards, make sure you take full advantage of the SQL features that Oracle provides. In other words, don't do it in PLSQL if you can do it in SQL. Qualify every identifier in PLSQL statements. In other words, table.column, procedure.variablename. Dot qualify references to all Oracle supplied objects, sys.dbms output, sys.dbms SQL. Use select into for single row fetches. Do not use explicit cursors. And most importantly, and most challenging to do, hide SQL statements behind an API. Encapsulate your SQL. So these are the topics that I'll be covering in the Best Practice series and in Say Goodbye to Hard Coding. But they're good things to be aware of, at least at a high level. Okay, so I've talked about the importance of setting standards. I've talked about the 3 key aspects or areas in your application in which you need to set standards, which is in SQL, error management, and basic coding standards and naming conventions. Now I'd like to finish up by talking about the importance of verifying that standards are being followed. It is, of course, very important to set rules on how all the developers on the team should write code. But if that's all you do, it's not going to be enough. You have to make those rules and those standards as active as possible, and I showed you how to use templates as one way of doing that. And you need to check the code afterwards for compliance. If nobody checks, if nobody cares whether or not you're following the standards, then we will not follow standards. It's just the way it goes. So how can we do this? Well, there are a variety of techniques for verifying standards. There is peer or team code review, a manual process. You can execute queries against various data dictionary views. You can use a really cool new feature called PLSQL. Compile time warnings in the Oracle database, and IDE-based analysis tools. Most of these will be covered in much more detail in my series on effective management of PLSQL code. So I'll touch on these things here, but I'll only give you a flavor of what's possible. Check out the separate series on effective management to get at all the details. So first of all, peer or team code review. Theoretically, ideally, none of the critical pieces of your code, and what's not critical, should make it into production unless another human being looks it over first. In other words, if we work in teams, almost all of us have team members, 5, 10, 20 members of our team, but even then we tend to write code alone. I'm responsible for writing program ABC. I write program ABC. I test program ABC. I check it in. And other people generally don't look at my code, and that's a bad idea because it's very important to have another human being give you another perspective. Did you follow the standards? Is there a better way to write that algorithm? And so on. Now you could go extreme with pair programming. That's a part of the extreme programming methodology in which nobody writes code by themselves. 2 people in front of every machine, one person doing the tactical process of typing, the other sitting back and being more strategic, making sure that standards are being paid attention to, making sure you're using the best features of the language, making sure your algorithms make sense. Very few organizations use pair programming, but it can be a very powerful mechanism. But more generally, I think that it's extremely important to have team meetings to review code because they help in a number of ways. Actually, the most important benefit of the code reviews as a team is not so much to find bugs and fix them. You'll certainly do that, and in fact, you'll uncover deeper bugs and improved ways to write your code. But more importantly, you will share knowledge about applications and programs within the application area. Whoops, sorry, I seem to have left out a word there. So basically, instead of having individual developers with their own areas of expertise in the domain around which the application is built, and therefore not sharing the information, and when you leave the team, that information is lost, instead you share that domain knowledge. And same thing with technology expertise. Even a senior developer on the team will specialize in certain areas, and I, a junior developer, might have gotten deep specialization in, say, pipeline table functions. Well, if we meet and talk about the code we're writing and critique it and share ideas, then we will also share our technology expertise. So team code reviews are a great way to equalize the members of the team, pull everybody up, as well as uncover bugs and find better ways to implement your application code. Now beyond that manual process, which is very intensive and you can never cover all of your code, you should look for ways to automate the analysis of your code. And certainly one of the ways to do that is to take advantage of underlying data dictionary views that give you information about your code. There are many of these, again, covered more extensively in the Effective Management series, but one of the most common and accessible is all source. This view gives you access to all the source code that you can execute, and you can run queries against that source code to find out if people are following the standards. Now I've created a program called valstandards.pks pkb, which is a very simple example of this kind of use of the all source data dictionary view. So in my package spec, I say, well, show me all the programs with a certain string, and that does a select from the table. Find me all the violations of my exception handling best practices. Check for encapsulation compliance. Let's take a look. So the val standard package body, program with, basically says, find all the lines of code in my user source data dictionary view that contain a certain string. Very simple. Just check for the presence of a certain string. And then I'll apply that for my exception handling review, which is find all the programs that contain a call to raise application error. All the programs that contain a call to exception init, that contain -20. My best practices for error management is to never make calls to raise application error. At least carefully decide where and when you're going to use exception init, and don't have any hard-coded -20,000 error numbers. And with this package in place, and let's define the package. And let's try it out by calling my exception handling program. Val standard exception handling. And let's save that for the next time I want to do this. I'll run this, and it might take a little while because it's going through a lot of source code in my all source data dictionary view, but that's the beauty of it. Even if I have hundreds of thousands of lines of code, it'll look through it for me in a relatively small amount of time, and it will find all the occurrences of code that matches. Whoops, bulk bind, truncated bind, what? I've certainly never seen that error before in this code. Truncated bind. Well, I'm not sure why that's happening, but just to get this over with more quickly, I'm going to add a row num less than 100. Just get me the first 100 rows that satisfy this request. Looked like it was having trouble with all the data it was returning. And here's the check for my validation of standards, checking for presence of raise application error. And it found raise application error in all these programs. And now I can go back through this code and find out, is that a violation of my standard? Should I change it? What do I change it to? Check for the contents of -20, etc. So that's the basic idea behind validate standards. Just use the user source data dictionary view to find the information. Now there's lots more you can check, lots more different data dictionary views, such as all identifiers, which is a part of PLSQL. But again, check out Effective Management for more details. Analyzing program unit structure and header. So all source is really nice for just checking the contents of the source code. But it's also very free-form text. And there are other views that give me more structured information about my programs. For example, all procedures gives me information about every subprogram I can execute. All arguments gives me information about every argument of every subprogram I can execute. So for example, I could say, show me all the programs that have a parameter of type fixed length char, char, or longs, because I want to convert them to lobs. All procedures. Find all the procedures that are authID current user or authID definer. And check out these different data dictionary views for examples of using or leveraging the data inside these views. PLSQL is a very powerful code analysis tool introduced in Oracle 11 that gives us the most detailed analytic capabilities to analyze our code. For example, with PLSQL, or let me back up, with all source I could say find all the programs that contain a variable named XYZ. But with PLSQL, I can answer questions like, Where is a variable assigned a value in a program? Where is its value possibly changed? What variables are declared inside a given program? Show me only the declarations. Which programs call another program, taking me down to the subprogram in a package. In other words, which of my program units depend on package A.program B, which is not available in the dependency information views, and find the type of the variable from its declaration. So PLSQL in general gives me access to information that was never before available. And the way it does that is by populating a view called All Identifiers. And again, what I wanted to do is simply make sure that this is known to you, that PLSQL exists in Oracle 11. And in the Effective Management series, I will go into detail about how to use PLSQL and what it does for you. But if you're interested in getting answers to questions like this, PLSQL is the answer for you. In addition, Oracle offers a compile time warnings framework that I can enable and get information back about the quality of my code. In other words, my code might compile. I might not get any errors in my program when I compile it. But it could be that there are a number of problems with the way I've written my code, and Oracle will actually automatically give me recommendations telling me, well, Stephen, maybe you should add the no copy qualifier, or your program might not always return a value, or some of your code might never actually run. And these are analyses that Oracle will do for us automatically. And that's a part of the compile time warnings framework, also addressed in more detail in my Effective Management series for PLSQL developers. So check that out as well. And let's draw some conclusions. Without standards, every developer is free to write code however they wish, and they will write it in very different ways. The result is code that is quite difficult to maintain, certainly even difficult to understand, because everybody's code looks different, everybody approaches things in a different way, and there's no standardization. So standards are key to maintainable code, simply at the level of being able to understand what people wrote. And developers should welcome standards. It makes us more productive. It improves the likelihood of success of the application. Don't fight against standards. Say, give me more standards. Free me up to spend my time focusing on really interesting aspects of implementing user requirements. Now, I covered a lot of features or aspects of PLSQL that relate to standardizations which I did not explore in full detail. The standards for error management, the standards for writing SQL, and many aspects of managing your code base using PLSQL, using the underlying data dictionary views. So I've pointed you out to the different series in my PLSQL channel trainings that will give you the details. And do check those out. Error management, effective management of PLSQL code, writing SQL in PLSQL best practices. So lots more to explore from here, but hopefully now you have an understanding of the importance that standards play and the areas in which standards must be applied. Next steps, download the demo zip. You can certainly take a look at the various files that I reference in this lesson, and then watch the other lessons in this maintainability series. So the importance of regression testing is part of the introduction, key techniques for readability, and modularization techniques. And of course, please do also check out the other series on effective management, error management, and writing SQL. Thanks for joining me. I hope this was of interest to you and you see the importance